Now let's look at correlation. Correlation is another statistical metric that is computed between two numeric variables. Both the variables has to be numeric in nature, right? You can compute the correlation between two numeric variables in order to quantify the strength of their linear relationship. And this value lies always between -1 and +1. So what does this mean? When it is -1, when the correlation between two different variables is -1, it means that both of these variables are correlated negatively against each other. What it means is when the value of one variable increases, let's imagine this to be the case. Let this be variable 1 and the other one be variable 2, right? When one variable increases in this direction, variable 2 decreases. You must be looking at a plot that looks something like this if you try to plot it. When variable 1 increases, the second variable decreases. This is negatively correlated. On the other hand, if it is positively correlated, the correlation would look something like this in this direction. The points would be distributed in this direction. Right? This is positive correlation, and this direction, the negative slope, is negative correlation. Now, how this would be practically useful is in housing prices data set, you might typically have a couple of columns. Say you have the prices as one of the column, of course, right? You have the price. You also have the area as one of the column. You will typically see that as the area of the house increases, as the area increases, price also increases in the same direction. Whereas if there is another variable where on increasing that variable, price decreases, then that would be negatively correlated. That is how you can quantify the relationship, the linear relationship between these two variables. Now, finally, let us understand the concept of probability distribution. What this tells is basically it's very simple how a given variable is distributed. That is probability distribution. And there are so many types of probability distributions available in the real world, but the most commonly seen types of distributions are the normal distribution, uniform distribution, binomial distribution, and Poisson distribution. Out of these, the most common distribution is nothing but the normal distribution as well as uniform distribution. Both of them are very, very common. Let's now look at how to read a normal distribution. A normal distribution is typically characterized by a bell-shaped curve that looks something like this, right? In this, to describe this curve, you need just two parameters, the mean and the standard deviation. With only these two parameters, you can describe any normal distribution. The mean represents the central location of the data, where the maximum amount of the data is actually located. This is the mean. And the standard deviation represents how far and wide this data is being distributed. That would be described by standard deviation. So in a normal distribution, if you take the region that is +1 and -1 standard deviation in this region, if you take this particular region, all the data points that fall under this particular region, it will constitute about 68.3% of all the data points. If a given random variable is following a normal distribution, 68.3% of all the data will fall under this range, ±1 standard deviation from the mean. Likewise, if you go 2 standard deviation up until here, it covers 95.5% of the data. Likewise, for 3 standard deviations, ±3 standard deviations, it covers 99.7%. These are some of the characteristics you would expect from a normal distribution.